Hi guys, the agenda of the today's session is talking about operators and constraints in SQL. So we'll be discussing what are the operators used and how to specify constraints. So operator is a reserved word or it's a character used in where clause of an SQL statement. It is used to specify the condition in the statement. First category is arithmetic operators, and these are the arithmetic operators: addition, subtraction, multiplication, division, and modulus, which gives the remainder. So let's consider the values like a equals to 5 and b equals to 10. Then we can specify the operations like a plus b, which is 5 plus 10 is 15, like 5 minus 10 is minus 5. Multiplication of these two is 50, division is 0.5, and a mod b, which is equals to getting 0. So we can also use these operators in writing SQL statement. And we can also use bitwise operators, which works with bits in the two expressions. And remember, it is applicable on integer data type only. So you can convert your numbers into binary bits, and then it applies add or not. Sorry, this is and. There is a typo mistake here. So and or not. So these are the operators used. So let me take an example for this. And for example, so let us create a database. And in the last session we have learned how to create a database, how to create a table, and how to insert values into the table, and then how to select a set of records from the table, and how to add new columns, and how to drop a columns, so etc and etc. So for more information on the basics of SQL, you can refer part 1. So here we are creating database. Syntax is create database if not exists. If this database doesn't exist, then it will be created, or else you can reuse the existing one. So create a database. If not exists, DSP, this database is created, so it's already exists, so that's why we have got the message DSP database exists. And I would like to specify the database which is under use, so use DSP. And within this database I'm creating the first table, that is employee. So the syntax is create table if not exist. The name of the table is employee, and the fields are employee ID, and the data type is integer, and we are making this column as primary key. So what is primary key? We are going to talk about that in the same session. And then next field is first name, and the size of this is varchar of 10, and defining one more attribute or last name varchar of 10, then specifying the age integer. So here this SQL is not a case sensitive, so you can write the column name in capital or small, it doesn't make sense. And then sex here gender varchar of 6, then salary, the data type is float, annual bonus float. So this table is going to be created, so it already exists in my case. And now I would like to describe the table. So describe table name. So this is the description: employee ID integer, and it's a primary key, and the other fields are first name, last name, age, sex, and then salary, and then annual income, annual bonus. So these are the fields. And how to insert data into this table. So here I'm adding four records. So the syntax is insert into table name, employee, values. So this is going to be the first row. The number of values should be matching to the number of fields. So the first row is inserted, then second row, third row, and fourth row. So the four records are inserted. I'm already having these values. So then I just want to select star from employee, or else let me just drop this table. Okay, so what is the syntax to drop a table? Drop table or employee. So let me run this command, drop table employee. It's dropped. Then creating a table, It is done, no error. Then describing the table, this is the description, and then I'm inserting 4 records based on the fields. So insert it and then select star from employee, so it shows all records. So these are the inserted values. So on this we can apply addition operations, even also bitwise operations. For example, here I'm using arithmetic operator, that is plus. So select employee ID and then salary plus annual bonus. These two are added and we are referring the column as employee total earning from employee. Then the result is going to be 2 columns, employee ID, and new column is created, employee total earning. So we have used addition operator, salary plus annual bonus, and we are referring it as employee total earning from the table employee. And next I would like to add a new column. So alter table, adding the column deductions, and the data type is float. That is going to add a new column. Done. Now if you want, you can use this select star from employee. So new column has been added, deductions. So after this I want to update. So update employee, set deductions is equals to 200 for the particular employee, like where employee ID is 101, specifying the deduction value as 200. So only single record is updated. Now select star from employee. You can see the deduction 200 added, updated to the employee ID 101. Next I am selecting employee ID and then salary deductions, right? Salary deduction as final earning. So not deduction, this is here we are using the operator minus. So salary minus deduction, and we are treating that column as final earning. Okay, final earning from employees. So this is going to be created, and you can see employee ID and then final earning. So what we did, we have subtracted deductions from the salary. After that, these are the values. I think original value was 20,000 for the employee ID 101. So after subtracting 200, the resultant value is 19,800. So here we are using minus. And how to use a star multiplication operator. Here I want to increase the salary by 2 times. So selecting employee ID, salary multiplied by 2, as the new field is revised salary from employee. That means it multiplies the salary value, and then we'll be getting the new field, new column, that is revised salary. So 101, right? And the salary, original salary 2000 multiplied by 2, which is equals to 40,000. Similarly for the remaining records. So we are using star multiplication. Then how to use division. So here I would like to reduce the salary by 50%. In that case, we can write an SQL query, select employee ID, salary divided by 2 as new salary from employee. So the salary is divided. You can see 20,000 divided by 2, which is 10,000, like this. Next, how to use bitwise operators, means you can work with the bits, and it is operated on integers only. So I'm selecting salary and also annual bonus from employees, and here in between these two variables I'm using AND. You can see the numbers. The resultant column is salary and annual bonus, and two values are ANDed, and then the resultant values are these. We can also use OR operator. So select a salary or annual bonus from employees. So OR operator applied on two values Then the resultant column is salary or annual bonus, and this is the resultant value. Next, we can also use comparison operators. The other type of operator is comparison operator, like less equals to and greater than, less than, greater than or equals to, less than or equals to, and not equal to. So let's take example for this. So greater than can be used in the where class, or select star, all fields are selected from employee where salary is greater than some number. You're writing the condition, then the employees who are having the salary greater than 10,000 are given as result. So you can see all these employees are having the salary greater than 10,000. And we can use and logical operator and. So we have the logical operators also. Like similarly, you can use these operators, depends on the requirement. Greater than or equals to, less than or equals to, not equals to, equals to in the where class. The next is compound operators. The next category is compound operator. So using the combination of these, like plus equals to, minus equals to, this is multiplication, division, modulus, and this is exclusive OR, and this is bitwise OR. And you can also use logical operators, and, or, between, not, like, in, any. So and means the resultant value is true if all the conditions are separated by and is true. That means based on the AND gate, OR gate, NOT gate. I hope you guys know the truth table of these AND, OR, NOT. So based on that, you'll be getting the resultant value, either true or false, depends on the truth table. So OR means true if any of the conditions separated by OR is true. Between means you can specify the range, and if the condition is satisfied, then you can get the values, get the resultant record. Not, and this is like. So true if the operand matches a pattern. You can define a pattern, regular expression like that, and then based on the condition you'll be getting the resultant or record. In, so it is true if the operand is equal to one of the list of expressions, or you can also use any. True if any of the subquery values meet the conditions. So let us take example for this. Here using OR. So using OR, selecting employee ID salary from employee where salary is less than or equals to 25,000, less than 25,000, or annual bonus less than 10,000. So we are using OR. Then the resultant value is this: employee ID and salary are selected, and these two conditions are applied. And in the next statement I'm using not, selecting employee ID, first name, last name, salary from employee, and where sex means gender. This is not gender, not male. Not male means we'll be getting the records whose gender value is female. You see there is one record and the gender is female, means not male. So the condition is satisfied. And we can use this like here I'm selecting employee ID, first name, last name, salary from employee, where last name is like K, means the last name starts with K, and then modulus. So the first character is K. You see here we have two records in which the last name is starting with K. Then we can use bitwise operator like this, from selecting employee ID, name, age from employee, where age is between 18 to 25. So the age should be between 18 and 25. Then based on the records age value, so we are getting the record. So here age 25, 25, 23, and these two values are in the range itself. So this is how you can use operators. Then we can also specify constraint. So constraint means is a condition specifies the type of data that can be entered into the table. So here there are two types of constraints: column level restrictions and table level restrictions. Means restrictions can be applied on column or restrictions can be applied on the complete table. So we have two types. The first example is not null, the not null constraint. So this constraint prevents the column from having null value. Okay, so there should be the value entered, it should not be empty value. So for example, creating table emp1 and the field is employee ID, the data type is integer, name varchar of 20 and not null, so name should not be null. So this is a constraint, not null. And the third field is city varchar of 15. So if you do not enter the value for this, then you'll be getting an error. So primary constraint. So the primary constraint provides distinct identity to each record. So for example, employee ID, student ID. So these should be unique. So there should be no duplication. And if you try to enter a duplicated value, then you'll be getting an error. So here I'm creating a table, create table employee 2. The fields are employee ID, making this employee ID as primary key, then name varchar of 20 and specifying not null. So this name should not be null, and age is integer type, and creating one more table, create table product PID, so product ID integer, primary key, product name varchar of 25 and not null, and the manufacturing date of the product, so which is date type. Now if you enter the values like whenever you are running this query, insert into product, the fields are product ID and manufacturing date, and we are supplying the product ID here and a date, but you are missing the value, so product name is not there. So but in the definition we have mentioned that name should not be null. So whenever you miss the name field, you'll be getting the error like field product name doesn't have a default value, so there should be value for the name. So this is how the constraint is applicable. Then how to create a foreign key. So basically the foreign key is used to connect multiple tables or two tables, and it corresponds to the primary key of different table. That means one key can refer the one key of the table referring the another table based on the common attribute. For example, here I am creating a table teacher, teacher ID is there, integer, primary key, name varchar of 25 and name not null, it should not be empty, and age is integer, department ID is integer, and you can create a foreign key like this. So foreign key department ID, so department ID is a foreign key which is referring the table department, and within the department what is the field? The field is department ID. Or in another way you can also create a foreign key like create table teacher, all these things are same, and from here department ID integer, and then you have to add a field like constraint, and this is user defined variable, foreign key department ID, this is a constraint here, it is, so this is a foreign key department ID referring references to department, within the department ID. So in this case, in this way you can create a foreign key. So there are two ways, so let's see this. So for example, creating a product table and making it not null, the table is created, product already exists, so you can drop it. So let me drop here, drop table product. Let me run this. Table is dropped. Then creating a table again with the field product ID, product name, not null, and then manufacturing date. Then whenever we enter like this, insert into product, specifying the fields, product ID, manufacturing date, values. This is product ID, name is missing, then we are specifying the date. So this will give us an error. So you can see field product name doesn't have a default name. Then how to create a foreign key. So create table department. First of all, I'm creating a new table department. The fields of this table are department ID, integer, primary key, then department name, varchar of 30, location ID. So this table is created. Then creating one more table. Create table teacher, teacher ID, integer, primary key, name, varchar of 25, and making it as not null. Then creating a new field is integer type, and then department ID integer. And so foreign key, we are specifying what is our foreign key. So foreign key is department ID, which is references to the department of department ID. So this is going to create a table. So this table is created, and this is the first way. Or the second way is you can create like this: department ID integer, then we are adding a constraint is this foreign key department ID, and we are specifying foreign key is department ID, and it is referring to the department's department ID. So in this way also you can create a foreign key. Okay, this is already exists, right? But if this table doesn't exist, if you run this through lines, then there will be no error. And you can also have unique constraints. You can have unique constraints, like unique constraint ensures that there are no entries with the same value. Means the field should not be having the same value. So you can specify the condition. So here I'm creating a table, names, and ID integer, not null. So ID should not be null, means you should specify the value. Then creating another field, name, age is integer, and you can see here unique of ID, means ID is unique. And here I'm inserting into names, ID, name, age. So first I'm inserting one ID value here, name is Ramesh, and age is 25. So if you enter another record with the same value here, primary this ID 1, so this should generate an error. So let us see this. So to creating table names and then specifying unique of unique ID. So this new table is created. Then I'm inserting the first record with employee ID, so ID value 1, and then trying to enter one more record, but employee ID is already there, so you'll be getting an error. You should be getting an error. You see, duplicate key 1 for key name ID, so it is generating an error because we have mentioned it's unique. And there is also check constraint. Means it checks the record. It checks the record. It is used to verify the values being entered into a record. For example, we want to have the age value which should be greater than or equals to 18. So we can specify the constraint. So creating a table student here, and then the fields are student ID, integer, primary key, name is varchar of 25, age is integer, and at last we are specifying the constraint. So check constraint, check in the bracket, you can specify the condition. So age greater than or equals to 18. Next I'm trying to insert one record into the table. Insert into table name and then values. So this is a value, and name is Rogers, and the age is 15, but which is violating the condition, age greater than or equals to 18. Then you should be getting an error like this: check constraint student check 1 is violated. So let us run this. So creating a table student, then of course table already exists, so I should drop it. I should drop, let me drop, so drop table student. Table is going to be dropped, and then creating a table, created, then trying to insert the record, insert into student values, but here I'm specifying the age value as 15, which should violate the condition. So when I run this, you see there is an error, check constraint student chk underscore 1 is violated. So this is how you define primary key, foreign key, and we have seen with examples the different types of operators. So while creating or while writing an SQL query, so you should remember all these because the basics matter. So if you don't know what are the different types of constraints, and how to specify the conditions in where class, so all these basics are important. So that's it from today's session. So we'll connect with another interesting video on SQL. So do follow, do subscribe, and do like, and also do comment.